So, let's just talk a tiny bit more about this. Yeah, so I guess maybe I should put on the board, maybe you already wrote it down in your notes, but if 0 ends up being in your confidence interval, then you don't have evidence that the two means are different. Okay? There is a difference between means. Okay. Need to say anything else about confidence intervals? I think this is it for this chapter. Okay, so chapter 6. Okay, and that will be as far as we cover on the midterm exam next week. Okay, so I thought maybe with this last bit I could just throw some problems at you guys, and you guys can identify gaps in your knowledge or whatnot. Yes.
I have a question.
Yes,
So
absolutely.
when you did this confidence interval for the two groups, and then you first did the two confidence intervals, one for men, one for women, and you showed us the overlap, and then now you did the difference between the two.
So
I
this is
noticed
the
that we
correct
did-
way, okay?
Okay.
To do it for a confidence interval for men and confidence interval for women, that will not give you a
So that was
true.
just to kind of show us.
Yeah, that was kind of to
Oh,
show
okay.
you. That might lead you to the conclusion that there's the
Overlap.
intervals overlap a little bit, so maybe we can't say there's a difference.
But
between the two
normally
means.
we'd be looking for the confidence interval of the difference.
Right. It depends on what the question is that you set out to answer. Okay. And so, if you're just asking what's the mean height of men, then you create a confidence interval for the mean height of men. And what's the mean height of women? You create a confidence interval for the mean height of women. Okay. If you want to say, is there a difference between the mean height of men and the mean height of women? Then you create a confidence interval for the difference. Okay. And if that interval does not contain 0, you've got evidence that there's a difference. If the interval does contain 0, then you don't have evidence that there's a difference. Okay. All right. Okay. So shall we just try some stuff, or do you have more questions, or are there particular things? Yes.
I'm curious, what if you have more than two groups that you're comparing?
Yeah, we're going to learn how to handle a situation like that much later in the class in ANOVA, in the topic for ANOVA. Okay, but yeah, doing confidence intervals for a difference, it only works when you have two groups to compare, right? Because how do you take a difference between three people? You can't. Okay? You can say person A is taller than person B. You can say person A is taller than person C, and person B is whatever, shorter or taller than person C. It doesn't matter. But there's no statement that you can make about, I don't know. Well, maybe our English language can handle it, but not the mathematical operations of plus or minus that we have. Okay, so let's just try something out here. If I don't know if I already did this one. So let's say this is and here you get $4. And you just have this thing. It's like Wheel of Fortune, okay? Alright, so I'll say what is the mean money you will win? Now ask what is the standard deviation? Do you need help getting started, or should I just let you keep working for a little bit? I don't know if I should write or let you work.
No.
Go ahead?
Yes.
Okay. Alright, so I'm setting up a table here, okay? You can either win $0, you can win $1, or 4. Did I mess something up? I don't know. Oh, maybe I put in 5 on the calculator. Oh, I think I messed that up.
Did anybody get 1.5?
No.
1.25.
I got
because
1.25. I was like, what am I doing wrong?
On my calculator, I punched in the wrong thing. I'm sorry.
I was like, what am I doing
Sorry.
wrong?
I realized as I'm filling this out, I'm like, oh, I put 5 in my calculator. So thank you. Okay. 0. Okay, so you have probability of 0.5 there, 0.25, 0.25. So when you multiply this out, so you get y times the probability of y, and I get 0.25 and 1, and I get 1.25. So that's my mean here. Okay. And now let me just do difference here. I'm sorry about that. It's freaking you all out. So speaking of gaps So then to get the standard deviation, we got to figure out the variance. So we're going to take the difference between each possible outcome, the y and the mean. Okay. So 0 minus 1.25 is going to be negative 1.25. And 1 minus 1.25 is going to be negative 0.25. And 4 minus 1.25 is 2.75. Yes?
Can I ask why you don't do the 0 one twice, because it's on the wheel twice?
That's why it's 0.5.
Yeah, I do put it on
sorry.
twice, but
Okay.
I have the probability of 0.5.
Gotcha, okay.
Yeah. Okay, and then so now I square it. So in the calculator, I'm just punching in all of these things. So I'm doing 1.25 squared, and I'm multiplying it by the probability of getting that. So I'm going to multiply by 0.5, and then I go to the next number, 0.25 squared, and I multiply it by that probability, 0.25. And then I multiply the last one, 2.75 squared times 0.25. And then lastly, I take the square root of all of that. So, yeah, I'm sorry, I typed in the wrong number in my calculator. So 2.6875. And then I take the square root of that to get 1.64. If you want the relevant formulas, so some of you guys love formulas. You can do that, and of course, if you want the standard deviation, you take the square root of that. Okay, let's say, what if we play the game, play this wheel game, 6 times. What is the probability that when the $4 Okay, so this one is binomial, right? Okay, we're playing 6 times, n is equal to 6, and the probability of winning the $4 prize is 0.25. And here, my k is equal to 2. I want to know what's the probability I'm going to win twice. I'm going to do 6 choose 2 times 0.25 squared times 0.75, or 1 minus 0.25, to the n minus k, 4. And when I do that, we should get 0.296x. So there's about a 30% chance that you win the $4 prize twice. So, are there any questions? Anything feel unfamiliar or uncertain? We good with everything? Let's try this. So, select 10, whatever, line locates. Wait. .7 grams is probably way too big. It's a heavy bean, genetically modified. And then I'll also, part 2 will be about additional calculations. this is what I got, 0.642 to 0.758, I think, unless I did something wrong. 0.7 plus or minus for a 90% confidence interval and 9 degrees of freedom. So I've got n minus 1. I'm using 1.833. And I use s.1 over the square root of 10. Is that okay? And okay, so this is what I got. I hope that matches the numbers you got. All right, so if I were to make a 95% confidence interval, what would happen to my interval?
It would be wider.
It would just get wider. Okay. Because the only thing that's going to change is this number. It's going to go from 1.833 to 2.262. Okay. So that changes up. Okay. Are there any questions on anything? Okay, we're good. We're just chugging along here. All right. So I drew this thing of beauty here, and okay. I don't know what this is. Ages in some club. Okay. What is again? Okay. What percentage of people are over 60? What percent of people are between 40 and 60? So let's let me just say this box is at 40 and this end edge is at 60. Okay. If there's any questions, and this number is at 55. It might not be so clear in your.
Wait, no. Your tail is at 80.
That's a whisker.
Huh?
What?
The outlier is
So would the age of 89 be an outlier? So I'll explain over this. Outliers would be over 90 and below 10.
Mhm. Gotcha.
Okay, so the median, you can see that straight from this middle line in the box. That's gonna be the median. What percentage of people are over 60? Okay, so 60 is Q3, so that means we've got 25% over Q3. Okay, so I've got 25% between 55 and 60, 25% between 40 and 55, and 25% between 15 and 40. Okay. What percentage of people are between 40 and 60? So this is the box, so 50% is right there. And then would the age of 89 be an outlier? Okay, so here we would see that the IQR is 60 minus 40, so we have an IQR of 20. And then I go 1.5 times the IQR over Q3 and 1.5 times the IQR below 40. So here my IQR, 60 minus 40 is equal to 20. So 1.5 times that is equal to 30. So here I would draw my upper fence at 90, okay? So 89 would still be within the fence, so if I did have a point at 89, then my whisker would extend up to 89. But it wouldn't extend beyond 90, so anything beyond that would be considered an outlier. Again, my lower fence would be 40 minus 30, and so anything below 10 would be considered an outlier. So this is a sample of some people selected. I asked, do you consider yourself liberal, moderate, conservative? And did you or did you not vote for Obama in the last election? So I will ask. moment or do the answers? Okay. I hope my answers are right. Maybe they're not. I might have made a mistake. I don't know. But okay. So probability that someone did not vote for Obama, there was a total of 75 out of 165. So this is just 75 out of 165. Okay. Did not vote for Obama, given that they were conservative. Okay. So here we're limiting ourselves just to the conservative column. So out of 55, 45 did not. Okay, so that would give us that number. If they self-identified as liberal, okay, we're limiting ourselves to this column of 55 people, and the probability that a liberal person did not vote for Obama, 5 out of 55. Okay. Vote for Obama and moderates. Okay, so here we're just asking if I selected 1% at random out of all 165 people, what's the probability that this person voted for Obama and considers themselves moderate? There would be 30 out of 165. That would be that one. And then lastly, what's the probability if I select someone at random? What's the probability that they either voted for Obama or consider themselves to be liberal, or both? Okay, so here it would be basically these four cells. So I could add all of those two together, or I can do the probability that A and B is equal to probability of A or B is probability of A plus the probability of B minus the probability of A and B. So this would be 90 over 165 plus 55 over 165 minus 50 over 165. Okay, so this gives me 95 over 165. Okay. Have we had enough? Or you just want to go home? Or do you want to do more drills? Okay. Well, I'll let you guys go early. So there's more stuff listed on the website of things to study. Okay. Obviously, we didn't cover everything. This is just a little practice session here. But study and good luck. We'll see you guys next week.